Hey everyone, in this video I'm going to solve LeetCode question 1471, the k strongest values in an array. So given an array of integers r and an integer k, a value r of I is said to be stronger than value r of j if the absolute value of r of I minus m is greater than the absolute value of r of j minus m, where m is the median of the array. Now, if the absolute values are equal, then r of I is said to be stronger than r of j if r of I is greater than r of j. The problem wants us to return a list of the strongest k values in the array and return the answer in any arbitrary order. And the median is as it follows the formula the length of the array minus 1 divided by 2, and yeah. So the example that I want to go through is example 3, and so let's begin with that. Alright, prepared some slides. Alright, so to start out with, we need to sort our array. So in example 3, the array given is 6, 7, 11, 7, 6, 8 with a k of 5. So this is our sorted array, and the median, according to this formula, we can see that it is 7. So we can go through an iterative approach here, iterating through values of k. So at k equals 0, for k equals 5, we're gonna do k equals 0 to 4 inclusive. So for k equals 0, we need 2 pointers, I and j. I will be at the first element and j will be at the last element. We can see that r of I is 6, r of j is 11, and the absolute value of r of I minus the median is 1, and the absolute value of r of j minus 7 is 5. And so if you look at this case, we can see that the value here is not greater than this value. So now it is equally valid to check the case where I and j are swapped. And so in the swapped case, r of I is now 11, r of j is now 6, and we can see that the absolute value of 11 minus the median, which is 5, and 6 minus the median, which is 1, this value is greater, and so our else case is actually valid. So 11 is the strongest, append it to the output array, and then remove 11 from the array. And so now our k equals 1. Our array is 6, 6, 7, 7, 8, and our pointers I and j are still point to the first and last element. In this case, we can see that the absolute value computations are equal. So we need to check the case where r of I is greater than r of j. So we can see that the swap case, in the swap case, r of I is 8 and r of j is 6. 8 is greater than 6, so 8 is the strongest. Append it to the output array, remove 8 from the array. Now k equals 2, and again we set the I pointer to the first element, we set the j pointer to the last element. R of I is 6, R of j is 7, and our absolute value computations show we have 1 and 0 respectively. Well, 1 is obviously greater than 0, so we say 6 is the strongest, append it to the output array, and remove 6 from the array. Now k equals 3. Again, I and j point to the first and last element. Now 6 we do the absolute value of 6 minus 7 is 1, and the absolute value of 7 minus 7 is 0. So clearly 1 is greater than 0, and that came from the 6. So 6 is the strongest, appended to the output array. Remove 6 from the array. K equals 4. This is our last iteration because remember, we started from k equals 0. So our array is now 7, 7. Again, I points to the first element, j points to the last element. They're both 7s. So now 7 minus the absolute value of 7 minus 7, 0. Absolute value of 7 minus 7 is 0. So now we have the case where we also have the case where the absolute value computations are equal. But remember, the problem said R of I is said to be stronger than R of j if R of I is greater than R of j. And so we need to check the swap case here. And this is basically just like an else case. So if we can see that R of I is not greater than R of j, and we can simply say else, just take R of j, which is 7. And so 7 from the else case here, highlighted in green, is the strongest, appended to the output array. Remove 7 from the array. So now our final output array is 11, 8, 6, 6, 7. Alright, so let's talk a little bit about time and space complexity here. The time complexity would be O of k, since we're iterating k times. The space complexity would be O of 1, since we just have the pointers I and j for each iteration, just to keep track of the first and last element in the array. If we just assume that the output array doesn't contribute to additional space complexity, then our space complexity would just be O of 1. All right. So as discussed, we need to start with a pre-sorted array. Oops. And we'll need a function to just give us the median according to the formula that the problem gave. Just want to make a quick note here that it needs to be sorted first. Yeah, or this won't work. We'll need an output array. Let's just call it strongest. And so here's where we're going to iterate through our values of k. Getting the values pointed to by I and j. Alright, so now we're going to write our logic as the problem described. So if absolute value of the I value is greater than absolute value of j value, then we accept the I value as the strongest. Otherwise, this is the else case, we just accept the jth value as the strongest. And then we want to remove that. Now remember, there's a second logic block here that we need to handle. It's where the absolute value computations are the same. So if they're the same, and if the I value is greater than the j value, then we accept the I value as the strongest. So we pop the value, we pop off the I value. Otherwise, and this is the else case, the strongest must be the j value. here we need to, at the end, we just need to return strongest. And so right here, we actually need to add a continue statement because for each iteration of k, we just want to make sure that only one value is changed, because if you enter this logic block here and your array gets modified, the set and the continue wasn't there, when you get to the second logic block, the pop functions might actually try to pop something that isn't even there anymore, which will result in an index error. So it's correct to just let one of these logic blocks handle modifying the array for each value of k. All right, so we've returned the strongest, and let's check if our example 3, if our code can pass example 3. Strongest. All right, so it's accepted. Yeah, let's try submitting it. All right, I think that does it for this problem. I hope this helps. See you next time.